All right. Well, welcome everybody to the Tom and Lonnie Chat. I'm Dr. Tom Kerpes from Georgia Tech, and we've got our friend and colleague Stephen Lamarca from AMT. Hey, Stephen.
Hey, Tom.
Unfortunately, Lonnie was having some technical difficulties today, so he sends his best to all his fans out there in TLC land. And today we've got a very special guest. It's the big man himself, Doug Woods from AMT. So, hey, Doug, how are you?
Dr. Kerfis, thank you for inviting me to your wonderful show. Sorry we're going to be missing our buddy Lonnie, but who knows, maybe he'll tune in partway through when he takes care of his communication protocol issues.
Well, you never know. He's out in New Mexico, and God knows what's hovering overhead over there. So we don't know. So
Can be an issue. Can be
yeah,
an issue,
we're
but
just
I'm
hoping
glad I could be here.
yeah. Well, we're just hoping we'll get him back at some point in time. But yes, no, welcome. Of course, it's exciting. We thought, hey, let's bring you on board. We're halfway, between IMTS 24 and IMTS 26, 2026. So we're wondering, what's new and exciting.
Geez, what's new and exciting in manufacturing technology? It's always the question of the day, right? And there's always something new, fun, and exciting. It was funny. I just got back from Europe a week or so ago, and a lot of people were asking the same question, as if somehow magically I know what every single exhibitor is going to be showing a year from now at IMTS. And I kind of I feel like Johnny Carson with the kind of Swami thing. Let me think and see what that might be. But
You're dating yourself there with Johnny Carson.
Yeah. I can make a prediction as to what it might be based on recent things that I'm seeing in the news and coming across my laptop and things I'm seeing when I'm traveling around other events around the world. I'm going to guess there's going to be a heavy kind of leaning and prominence of AI.
Yep.
So I think everybody and their cousin and sister is going to have something in their booth that says something about AI. Just kind of guessing. And I think you can watch the themes in general going all the way back like 25, 30 years. If you want to know just generally what's on everyone's mind, you can just walk by their booths and 70% of them will have some common words. And so back in the 80s, 90s, something to do with quality was there. That was the post-Juran Deming time, and everyone was doing something new and unique relative to quality. And then we started advancing a little bit more there, and people started just be getting a little more digital. Of course, the whole Industry 4.0, the best marketing thing the Germans ever came up with, was in everybody's booth for quite some period of time, and that was the next big novel. Everybody got a little bit green, 5, 6, 7, 8, 9 years ago, and everybody had some green theme going. We advanced slightly from green to where we're at today, in that smart manufacturing is where we're at. And I'm not sure what we were doing before when we weren't smart doing manufacturing. I'm also not sure what we weren't doing 10 years ago when we just became digital, when we were doing something digital back in the 70s. But I'm trying to follow along with themes here. So as we look forward, I'm pretty sure what you're going to see in this next thematic, which will be funny 20, 30 years from now when someone's doing this program with you, and they go back. Remember back in 2026, everyone was talking about AI in their booths. Do you remember that? That's where we're going. It's going to be an AI-centric event, and after that A, it'll be the A of automation and people elevating and advancing and commonizing or democratizing even from how automation is going to be used and used in the booths. And then if you go one more A after that, I think you're going to see some more applications and uses of additive. So of course, additive is going to be in the South Hall, which is a premiering kind of event from that standpoint. It's not so much just that, which is good all by itself. It's the fact that as you go around the entire show, you're going to see more things where additive is applied in many cases to things people are doing, showing in their different booths. And I think after that, we got to switch out of the A's and go over to D's and look at what's going to happen with digital twins. I think the play to people leveraging what you can do with GPUs and the capability of leveraging the tools that are now available to more easily create a digital twin with reasonable physics and kinematic modeling is going to be something else you see a lot more of in the software pavilions as people look at. It's a lot more obviously than CAD and CAM and even basic simulation, advancements in the software segment. So from 30,000 feet, that diatribe is where I see things basically going.
Yeah. No, I mean, I think it makes a lot of sense. So number one, I do want to point back. Just it's sort of fun to look in the rearview mirror for a couple of seconds. When did Additive first show up over at IMTS?
We did the first one at IMTS where it was a separate area, probably in 2014, I believe. 2014 or 2016. I think it was 14. We did the car in 2018, I believe it was, when we did make a car with local motors all at a show from the first day to the last day and drive it off.
You drove it off. You can go out there to YouTube and see, Doug Woods drive off the 3D printed car.
There you go. So yeah, we knew it was one of those things that was going to be out there and important. And as you know, the ETC, the Emerging Technology Center that we have at IMTS all the time, is looking at what are those things that are going to be happening, 2 to 5 years into the future, not necessarily what you're buying today, what's going to be out there in the future. And at that time, going back then to even 2014, you started to see like Additive being part of that pavilion. And a lot of stuff we did with, the folks at Oak Ridge and others, we picked some of those leading technologies and partnered to show them out there. And that's kind of how far that one goes back. You saw the same thing, you're familiar with that, what we did with MT Connect. MT Connect stuff went way back to like 2010, right, where we started figuring out how do you drop it into letting people understand what it is. It might have been 2008, frankly. And so it kind of shows where things are going, and that's kind of the Wayback Machine. The ETC is also a good way to take a look at what was the thing being shown at the ETC at a show going back into the 1990s and the early 2000s, and when did that technology actually gain traction? Some 3 to 5 years later, usually.
Yeah, no, it's amazing. So as you mentioned, 2014, 26. So 2016, that would have been 10 years ago, 2014 a dozen years ago, but it's amazing how things have progressed along. I was just actually sitting in another meeting where it hasn't been approved yet here in the U.S., but FDA, printing of joint replacements for people, where you go in, they do a CAT scan, they reconstruct it, so they make a digital twin. Now it's just a geometric digital twin, but then in a powder bed, they print hundreds of these things, and they're all mass customized, right? So if everyone's just a little bit different, customized to the individual person, their serial number is right there, and off they go. I know they're doing it right now in Mexico, Central and South America, and I know that they're working towards getting it approved here. It's amazing. It's absolutely amazing, where we've gone and the capabilities that we're looking at. And you mentioned MT Connect, of course, near and dear to all of our hearts. And I think our most popular podcast here is how to use MT Connect to connect your machine tool out to your Google Drive, so you can stream things out to Google Sheets and generate control charts and the whole bit. So, bits and pieces are going out there, and really that's also laying the foundation for your digital twin, and your AI, your artificial intelligence. Because what does AI need? It needs data. So all of a sudden we're starting to say, hey, we're getting all this data. What are we going to do? We work with a lot of companies, and you basically nowadays you not only spec out, hey, here's the type of machine tool I want a vertical mill, here's the volume, here's the spindle power and speeds, et cetera, but you're also specing out, hey, this thing needs to be able to communicate with MT Connect and so forth. So it's getting a machine tool is sort of really it's a different story today than it was even 10 or 15 years ago. Stuff has really moved forward. And one last thing, and you got me on my soapbox, but one of the things we're finding is we're helping a lot of different companies. They're like, geez, we've got these machine tools. They have all this capability, and we're still kind of running them. The only difference between how we're running them today and how we ran them back in the 70s and 80s is we're not running paper tape through them. Now we're sticking a memory stick on them and so forth. So a lot of this stuff is there, and what we're seeing is now people are starting to use it, and it's starting to be accessible. So it's exciting. But pivoting to the future.
Yeah.
What else is there, man?
Can I play off your MT Connect thing just for a second to kind of make this connection to cool in the future? So we developed that with the folks at Berkeley, back in the 2006 to 2008 timeframe. Yeah. Just saying the industry needed some interoperability standard for people to commonize what they're doing for data and interconnecting manufacturing technology equipment. It seemed logical. It seemed like an independent, non-proprietary company situation had to be done. So, we stepped in. And it basically did exactly what we wanted to do. And it's probably one of the most widely utilized tools for being able to actually do that connectivity and commonizing the data and having uniformity of the data so you can do different things with it. And it's kind of actually got a really interesting renaissance going on right now because of the coolness that's happening when you start talking digital twin and beyond. And where the connection is being made is that NVIDIA, of course, that is a major player with what they're doing with GPUs and is leading a lot of things even in the manufacturing sector, has really figured out that in order to do things well in creating the digital twin, especially if you want to get digital twins into the omniverse, you've got to be able to standardize some other things as it relates to actually the imagery or the pixels that go into it. So they're working with a group of people that are in the OAUSD, so the standard for Universal Screen Descriptor, which is that group of, just like MT Connect at the time, figuring out how you standardize the node or the pixel to impregnate it with more specific information.
Yes.
And so that, for animation, so Pixar's in on this, Apple's in on this, Siemens in on this, Autodesk is in on this, NVIDIA's in on this. And because of what they understood MT Connect was and how we've already cleared ground in that space, and it's a SysML based standard, one of the first standards ever SysML based, they've actually invited us into that club of those people I just mentioned. And it helps kind of build for them the stack of how do we move from actually animation that you might use in a Pixar film to actually moving all the way up into how do you put all the right information with the physics modules that people like NVIDIA have created to go get things into the omniverse. So you can create a digital twin anywhere you want. If you want to get it correct, you really need to have the physics models there. This USD standardization allows that to happen more easily. And then as people put their whole factory into something like the omniverse, because a digital twin is great by itself, but if you really want to see how things work in your factory, and no one has a factory usually with one piece of equipment, it's an integrated solution. Omniverse gives you that place of getting multiple pieces of equipment with the right physical models, the right kinematics applied, and actually be able to see then how you adjust in productivity and modify what you do in your facility. MT Connect is playing in at the ground floor of that, which is the cutting edge of the next thing to happen out here in the future space.
Yeah, and I mean along those lines, and we've been working with GPUs probably since the very early 2000s, before it was easy to do and so forth. But I mean, what we recognized is, when you're doing graphics, you're moving things around. So whether I'm moving an image or a model of my mill around, or I'm actually moving the mill around, there's a lot of similarity there and so forth. And things like if you look at games, if I'm running and I hit, or driving and I hit a wall, well, guess what? If I'm machining and I hit the fixture, same type of representation, so you can really see where these things come together. And and again, I mean, along your lines, I look at it and say, well, instead of so I think we all, just for everybody out there, right? You got the pixel. I think everybody knows a pixel is. A voxel is a three-dimensional version of that pixel. And we'll get to that in just a minute. But look, you got the voxel, and instead of being a color, hey, this color, and it can be 65,000 colors, whatever. Maybe it's a temperature. So now you got a casting reference. So instead of a color, it's a temperature, or maybe it's a temperature and a stress and so forth. So yeah, I mean, it really makes a lot of sense, and then it's right in line to be processed on GPUs. So now we can do, instead of just mining for Bitcoin, we can actually use it for manufacturing and things like that. But it's exciting. But here's the problem, right? If you think about it, just to make life interesting, let's say I've got a 1 meter by 1 meter by 1 meter block of material. So kind of 3 by 3 by 3 feet. If I want to go down to a micron level on that, so a micron is a millionth of a meter. So how many of those little cubic microns are in that cubic meter? And that's 10 to the 6th cubed. It's 10 to the 18th. I don't know. I don't even know. I have to go back and take a look, but it's really big. So it's sort of a very interesting problem, but, slowly but surely we're moving along in the foundations with capabilities like MT Connect are already laid. And so as we're moving technology forward, we're already there. We're ready to go. Now look out with your power bill. Maybe you're going to need a nuclear reactor next to your plant to run all the analysis. But hey, we'll figure that out as well. But it's very exciting.
If it just to drop a couple facts on fixing that energy problem, and so this is one of the other great things why the United States is one of the best places in the world to be in manufacturing. Manufacturing is going to do great here for years and years to come. The United States is a net exporter of energy. So not only is energy mission critical to things we were just talking about, you want to be in a place where you've got a lot of energy. So not only can we satisfy our needs here, we can actually afford to export 30% of our energy. Really big. Why is that really big? As it applies to AI and GPUs and this thing we're just talking about. The world has right now a little over 11,000 data centers around the world. 11,000. 5,300 of them are in the United States. We dominate the space of data centers, which you need to handle the processing that we're talking about here. And so you got the energy, we've got the data centers. We also have the innovation in the AI space to be able to figure out how we propagate this kind of new technology to solve things in our field. And so you've got the best mix of all these things in one place at one time. And again, sometimes we can go after the shiny object and like do all these things that we're talking about right now tomorrow. No, these are things though that when you look at the Maxwell chip that the folks over at NVIDIA are putting out, you look at what they're doing now also with the pipelines. Actually, it's not only just building the unbelievable processing power they're putting into their GPUs, it's also they're figuring out how you do that with less and less energy as you stack those in racks and build them into your supercomputer you're going to go use for an application. They're figuring out how to put more processing power onto those chips and how to do it with less energy in less space. I mean, you've got the right recipes for manufacturing technology to really be leveraging these tools in the US, dramatically impacting our ability to kind of lead in this overall manufacturing technology race.
Yeah. No, I mean, I think it's, and by the way, I mean, I would say this is something that we've been looking at for a long time, right? This is a very long-term, what we're seeing today are results of long-term efforts and so forth, because if you think about how long your laptop lasts and how much power you have in your laptop, I mean, the biggest issue is, well, how long is that battery going to last? Well, if we can use less and less energy, so this is sort of a bigger picture type of thing. But now you're seeing laptops say, well, hey, we've got AI built right into it. Okay, well, that's going to eat more energy. So it sort of it pings back and forth. So anyways, we have a little bit more time. But so okay, AI, very exciting. What else do you think we might see over there?
Yeah, I think, I was touching on it at the beginning with things relative to automation. I mean, automation is going to be the fastest growing sector in the manufacturing technology space for some time to come. So I think, and that's kind of goes without saying, and you're like, well, what's interesting about it? I think what's happening is automation that's coming out now is much easier to use. So where we talk about working with an app or doing things like that, we talk about UI UX, right? I think there's like a UI UX moment happening with automation to make it easier to program, make it easier to integrate, make it easier to connect, make it easier to understand. So when you think about 30 to 40% of where our manufacturing technology equipment goes in the US market, it goes to contract manufacturers. And many of those aren't really shops that are that big. Average shop size of a contract manufacturer is 27 people. And so you got to make this stuff easy to use if you want that automation to be deployed to fill in the gaps where we either don't have enough people or you don't want your talented person spending time at the machine when they could be doing the next application, when they could be doing the next productivity improvement with their brains that they've already got, knowing how equipment runs. And so I think this movement of automation being obviously already effective, more integrated sensor technology, but better UI UX, so it's easier to adapt and integrate, and already more modular, so it can be used in multiple different places in people's facilities. And so not so much hardened automation, but truly more flexible, portable, reusable, adjustable automation, I think is going to be a big play to see. And I think that's really interesting as well.
Yeah. No, I mean, I agree 100%. I often like it. I mean, when I give talks and, I go around to various, associations and societies and meetings and we talk about where manufacturing is going and how all this fits together. I mean, my example is people have a Fire Stick or whatever but the equivalent of a Fire Stick. It's got a few buttons on there with a pretty slick user interface, and it's way more powerful than, I think you guys are old enough to remember the VCR with the remote that had 500 buttons on it. And it was like, oh my gosh, you had to go to the manual to figure it out.
And you had to be kind to rewind.
Yep, there you go. There you go. And so, for those of you who didn't get that, sort of statement there, it has to do with, VHS tapes and so forth. And I think that's probably a blockbuster, which is also, now a relic of the past. But again, I mean, part of that shows you how fast technology can change things and move things around and the whole bit. And you've mentioned, a number of companies, for example, Autodesk. I've got kids showing up here at Georgia Tech, right? Georgia will put a plug in for old Georgia Tech here. But they've been doing a little 3D printing here and there, and so they've been using Tinkercad, which is a subset of Fusion, Autodesk Fusion, and they're all into it, and they can produce really quality drawings and parts and the whole bit pretty quickly. Now we take them to the next level, but they've made it really easy to use and fun, right? I mean, who wants to manually code G code, right? No.
And that's a challenge.
Sorry. I was just going to say, Tinkercad really is incredible. I mean, when I started at AMT in 2015, when the tech department wanted me to pick up on CAD to originally start building our test bed, Fusion 360, which is incredibly easy to use, was, comparatively to other CAD software out there, I started on Tinkercad first, and it was so cool because it actually had a bunch of curated lessons for you to get started from nothing to being able to design something. And if you really liked something that you put together with your virtual Legos, essentially, there was a button in the top right corner that said print, and Autodesk would actually manufacture it for you and ship it to you after paying a small fee. But, it's really cool. But I'm excited. Doug, what other tech companies, like Silicon Valley style tech companies, do you think will be at IMTS in 2026? Because you mentioned, a previous show being very green, and it's funny that 26 is going to be very green too, with NVIDIA being so present with AI and digital twin with Omniverse. But it's bringing in the fact that UI/UX is making everything easy to use, which is like the name of the game with Silicon Valley tech companies. What other companies do you think will be there?
Yeah, I mean, two sides of that. From an exhibitor standpoint, and I don't want to just pick on any one of them, but let's just say for namesake, some that were there last time. I mean, like the Microsofts and Googles of the world, know they want to come and play in this space, and it's important to them because because of this kind of integration now that's happening with where the digital footprint and digital technology and things with digital twins so gets into their space and they want to be part of the manufacturing. I think you're going to see more of those types of companies. I think it's equally interesting to look at it from the standpoint of attendees. You can see over time the attendees from, for example, SpaceX or Blue Origin dramatically going up. You can see the number of attendees from different types of defense contractors like Anduril, going from like only Lockheed and Boeing and Northrop Grumman to all of a sudden these startup companies that are making drones and whether that be for flight or sub or, on sea. So I think what is interesting to kind of look at, Steve, in answering that question is to map the demographic of the new industry types that the attendee groups are growing. When I mentioned like SpaceX and Blue Origin, they're bringing, like the last show, somewhere between 25 and 40 people, engineers, applications, lead people. And it kind of says how the newer technology companies are coming to IMTS to find the thing that makes their newer technology better, faster, to a higher level of quality. And I think that's as fun as looking at the people. And you can look online and see all the people that are exhibitors as of today, including some of those Fortune 100 ones that I just mentioned that want to be there as well.
Yeah. No, I think you're absolutely right. That I think the coolest thing that's going to happen at IMTS 2026 is going to be the inelastic collision of different companies, like the big tech Silicon Valley companies and gaming companies, seeing how they can get involved with manufacturing. And as you mentioned, the smaller like defense companies, I remember at IMTS 2024, I saw a team, like a pretty sizable group from Geisley in Pennsylvania. They're a small arms manufacturer that has defense contracts, and they were at IMTS seeing how, what new technology can they get involved with for some of their more advanced products. So it's going to be a really exciting time seeing all these sectors come together for manufacturing.
I mean, I agree. I think we'll come back and I mean, you mentioned some of the gaming companies. I mean, imagine, and you can start to see it now, right? I mean, programming your machines and your robots and the whole bit, and with a digital twin, as you mentioned, Doug, there are lots of similarities there. And Doug, you mentioned the P word, physics. Not F, but P, PH people. So, but the reality is these physics engines, the same ones that basically make these games real, are also able to model pretty accurately your machines and your robots moving around and things like that. So it's just super cool.
Yeah, and I know we need to kind of wind up, and I think we'd be remiss to not point out that today is, National Manufacturing Day, and I think we can sit here and take a look at like where we're at today with National Manufacturing Day, and just dial back 5 years, even 10 years, and go how dramatically we've advanced in this space. How interesting, cool, and dynamic, and critical to the national economy and our national defense. Manufacturing and manufacturing technology is, and as much as all the cool stuff is at IMTS, that kind of is the bling, which you got to see, because it's all the base companies, the tooling companies, obviously the machine tool company, the grinding company, the software CAD platform. The fundamentals of the industry are all also there. They're changing their game, and they're leveraging these technologies with the cool folks that are coming around the edges, also playing in the space. It is the one thing, the one place, the one time that you get all of that working together to drive what? Our manufacturing economy here in the United States, and it's awesome.
Right. Now, I think, go to IMTS, man. That puts the fun into fundamental, I'll tell you.
There you go.
That's an old professor joke. What can I say? All right. Well, hey, listen, so before we let you go, right, we'll give you 30 seconds or a minute. And anything you wanted to say to the group out there and so forth in terms of revving them up to get them signed up for IMTS?
I've been going back and forth kind of on this, and again, so I grew up in the industry since I was a kid. There is nothing better than being at IMTS, electricity, seeing, learning, go down to the Student Summit and look at 15 to 20,000 kids doing hands-on things with our exhibitors that partner with us to do things down there. And that's the next generation and the generation of what's going to be the future of manufacturing in the United States. If you're a potential exhibitor and you're not in yet, there's not a lot of space left. You want to get in. It's the biggest consumption market in the world, the United States. We're the biggest GDP in the United States. We are one of the most advanced manufacturing areas in the United States. So you want to be at the show that lets you show off your product and technology to the 100,000 people that are going to be there wanting to consume. And 80% of the people come to IMTS have purchasing power. They're making decisions about what's going to be purchased. This is the market. This is the place. This is the time. Be at IMTS 2026.
Yeah. Let me just add, Doug, you mentioned sort of the student, pavilion and so forth. Look, if you've got some kids and they're, even slightly technically capable or oriented in the whole bit, bring them, because I got to tell you, as far as I can see, Bob, if they can get into this area, they understand this, you can get them excited about it. They've got great careers ahead of them, and it is going to go out to the horizon and beyond. They're going to be talking about IMTS in 2040, 2050, 2060. It's still going to be rolling along, and we're going to need people in there. We're going to need those manufacturing personnel. So
you got it. Right with you.
Facts.
Very good. Hey, Doug, thank you so much. It was great.
Thanks for having me.
And certainly we'll see. Well, of course, we'll see you up on the stage at IMTS, but maybe we'll get you to pop in once in a while. Here and there. It's always a pleasure. Stephen, as always, you always have the best shirts, so there's no branding. I can see Doug did the branding, I did the branding, but Stephen's kind of, off on the well, it is, I have to say, everybody, you don't know what day it is, but it is Friday, it is National Manufacturing Day, so, it's Hawaiian Shirt Friday, is that right?
I guess so.
I thought
that.
Nice.
All right, guys. Hey, thank you so much.
See ya. Thanks.
All right, see ya.
Thanks, guys. Bye.